I'm not going to rehash the documentation. I think we have pretty good documentation. There are lots of tutorials and lots of getting started blog posts on Elmish. The angle I'm going to take is why Elmish exists in the first place and why we think it's a great way to build applications. A little bit about me. My name is Eugene Tolmachev. I'm principal architect at Prolucid, author of several projects including Fable Elmish, and I've been building software for over 20 years, but more importantly I've been building event-driven system for the past 8 years or so. And the reason it's important is because it gives you certain perspective. Building event-driven system changes one perspective from API and syntax to what does the system tells me about itself. What are the events happening in the system? Can it communicate to me that way? I just finished converting some of our internal code base to FS Shelter, which is another project for building event-driven systems on the backend. And we had another project coming up that would require mobile application, and I was tasked with investigating what do we have out there and how we're going to build it. And once I started looking around, I realized that I don't have the tools that I expect to find there. I don't normally write UIs. Now and then I surface into UI world to see what's happening there, doing some work there, but mostly I'm doing the backend systems. So I looked around and I saw that there's all these technologies in the native world that you can use, including just writing native applications using the tools that were intended for it, writing them with Xamarin. Didn't really like everything we've seen, so F# is an investment for a company. It's a strategic investment, and jumping the stacks may be appropriate if you're an individual developer, but as a company you want to invest in a single thing because let's face it, it's a very large investment, and it comes with its own restrictions. You have a hard time finding the right people, so jumping the stacks is not really an option for a company. We made the decision to go with F# for the backend, and we want to do the same for the front end. So looking at the layout of the land, I realized that we don't really have the tools that we need. Yes, we can do UI, keyboard and mouse, and pretty much with anything really. You can take the native tooling for that, you can take the React Native, and many other options. If your UI is simple, you can go with anything and you're not going to be wrong. But what about other things like platform and lifecycle events, local storage communications or network communications? The requirement we had for the product would have us specialized hardware connecting to the mobile device. How would we talk to that? What all these things have in common is that either by design or by choice, you have asynchronous ways of communicating with them. In other words, you can present whatever's happening as events. And once you start thinking that way, then really everything you can think of really can be represented as an event and can be dealt with in uniform fashion. And the good news, the problem has been solved, and has been solved in many different ways, and most notable is Elm and Redux. As long as it targets your platform, or you're willing to give up F# or most of its benefits. With Redux we have the binding. Some people prefer it that way. You can certainly work that way, but you'll be jumping in and out of a native F# all the time, which obviously could be fairly expensive. So once we started looking at what makes Elm successful, it's this model view update, or typically when people talk about Elm architecture, they talk about model view update data flow. And it's really simple, there's not really much to it. But if you think about it, Elm is immutable language. It doesn't really give you a way to mutate state of anything. So if all you had is model view update, your application would be fairly useless, because it won't be able to talk to anything else. So what I think makes Elm architecture so successful is that it's in fact model IO update, which looks fairly similar, but it offers a way to communicate with anything, not just with the rendering device. So we looked at it and decided, hey, languages are both in the ML family. Maybe we can reproduce it easily in F#. And looking under the hood, what makes the whole system tick is this little CMD type. The type is a container for effects, and the module, corresponding module, offers ways to work with it. Together they provide a way to unify all the program inputs and outputs in a single place. So that part is about why Elmish exists. It turned out that it's fairly easy to reproduce, what makes Elm successful. Now, what makes Elmish interesting to use, and how different people find this particular uses. Many newcomers to Elmish and to Fable ecosystem in general confuse it with React. They come in and start asking, how do I do this with Elmish, or how do I do that with React, when in fact these two are completely separate things. Elmish is all about managing the state. Presentation technology is really orthogonal, and that was built in from the get-go because what we wanted to do with React native applications, that didn't turn out to be the case, and we quickly pivoted and made it available for everything. The UIs are optional, and if present, unidirectional, and that's what people mostly think about Elm architecture, which is in fact unidirectional UIs. And there are many very different ways to do it. Some similarities here and there, but this is not really about UI. Elmish apps are immutable. Everything in the Elmish library creates new instance whenever you want to make a change. The side effects are expressed and captured in the CMD, and the actual work is carried out by the dispatch loop that you never need to see. Some people ask, so what's the big deal? Well, yes, you certainly don't have to write your programs in that way. You can certainly mutate state whenever you need to. But it makes certain things very easy. Well, one of them is it's easy to reason about immutable programs. We've all done that. We looked at object-oriented code and we start scratching our heads what's happening anywhere. You look at that pure function and you know that there's an input and there's an output, and that's all there is to it. So immutability makes other things possible. Time travel debugger is one of them, but also certain rendering optimization wouldn't even be possible in something that allows you to mutate state left and right. Elmish apps are state machines. Init function initializes it, update function implements transitions and triggered by the events. From seeing many comments internally and on the internet, I think this is the part that makes Elmish the most successful way to write applications, or most pleasurable way that people report. It's, I think it's actually amalgamation of the fact that we're using F#, and it has powerful facilities for pattern matching, which makes it very easy to write those functions. It's also a source of greatest confusion. People are used to maybe things firing events and some other components somewhere else, hooking up to those events and handling them transparently. Elmish forces you to do everything explicitly. You want some sort of wiring happening, you have to do it in the code. On one hand, it's an overhead. On the other hand, if it compiles, it works. Elmish apps are built of trees of interaction tuples. Triples. A triple is defined by state or message types, view function, update, and or init function. All of those things are optional, and each one of them can be written any way you like. But each of those triples can be written in such a way that it can be run as a program on its own in isolation. It gives very instant familiarity to anyone looking at any part of your code. If you know that it works a certain way, anywhere you look, it will instantly be familiar. You'll be able to find your way around it. A tuple is a unit of view. Some people were asking, where is the abstraction? Well, we're in the functional world. We don't need to introduce interfaces to communicate. We have functions, we have modules, we have ways of exposing and hiding those things. And you can use as much as you need or as little as you need. I've seen some components that don't have view at all. They just have state manipulation, or they don't have much in the way of UI, but they make some sort of subscription in order to communicate with websockets or anything like that. So everything is up to you, and everything is enforced by compiler. So again, no surprises at runtime. Elmish shops are routers. Your tuples type define the protocol, and parents and containers take responsibility for routing data to and from your components. The long-living interactions that they've first been exposed to writing backend services, which don't really establish long-term connection, so you don't have any pointers or anything like that, or sessions. You thread your communications, your messages, with some sort of correlation ID, and that gives you a thread of conversation. Even that thread of conversation, with the state machine, you can easily script one side of the conversation with one component, another side of the conversation with another component. That's what backend systems at scale do all the time, and this is what Elmish does implicitly. Elmish shops are interpreters. Tuples types define the language, and update function interprets them to compute new state. Interpreters and state or deltas can exist independently, and that's what gives the rise to time travel and debugger. We can export the state, we can load the state, we can write a completely different interpreter that does something else and load the state and see what happens. And a bit about ecosystem. So obviously there is Elmish Core, and the Elmish Core has been compiled for .NET Framework, as well as, well, primarily was developed for Fable, but with a few tweaks, we were able to compile it and use it in the native.NET. The views, React Native out of the box, and Inferno recently developed by Alfonso. There's a fantastic or interesting example of WebGL renderer, the experimental WPF port by one of my colleagues. Given the browser as a platform, there's a routing and navigation support that has been also ported from Elm. The React itself is a rich ecosystem, so anything that works for React will work in your application. If you don't use React, you could use Fulma that Maxime will be presenting or doing the workshop on tomorrow. Remote debugger integration, again, that's something existing in the React ecosystem. We're just plugging into it and it works for us. Communications, Nick is doing something interesting with WebSockets, where he transparently under the hood integrates WebSockets communications into the dispatch loop. Templates, examples, and tutorials made by the community, lots of samples. I have a hard time keeping up with Fable development, but there's lots of stuff there. And in terms of real-world applications, you probably heard about success stories from others. A bit of background about Prolucid. We help companies bring product to market. Sometimes they come with an idea, sometimes they have a prototype. Sometimes they have an existing product that they want to bring to the cloud and be able to manage remotely. MindTech Move is an interesting product that we have been working on for many years, and recently we've added management capability to update the various components of the devices remotely. So that's where Fable comes in. You'll never find it on the internet, but internally, administrators of those devices use Fable UI to manage those devices. For gate controls, we have developed the entire infrastructure connecting smart plumbing devices to the internet and allowing property managers monitor and remotely manage devices and see if there is a leak happening or plug off, turn on various plugs. For exact imaging and joint surgical, we also wrote a management backend with Fable UI that lets those companies develop updates at their own pace and deploy them to those devices. All those devices are highly specialized, so it's not like you could hook up to existing management infrastructure. So management Fable provides lots of capabilities on the UI management side for the administrators of those devices. And we're working with the car manufacturer that should remain unnamed on a couple of machine learning applications to improve the quality of their assembly. Again, we will be using management UI written in Fable for these applications. That's it. There's a lot more to find at Fable Elmish GitHub.io and at Prolucid GitHub.io. We have lots of components open sourced by our company, lots of bindings for Fable that help you build the entire stack, whether it's in the front end or the back end. So now I'll take the questions.
So is there any particular difference with Elm architecture as understood in the Elm language? So is there, the Elm architecture comes from the Elm language, and I think that you try to follow as much as possible the implementation of the Elm language, but is there any difference that will be worth noticing? Or?
Let's see. Right, so Elm being completely immutable doesn't really offer certain features that F# has. In order to make an implementation possible, you have to call something to the platform. And the way that Elm is designed, it does calls are basically commands. So that's the only way. Sorry, that's the only way to have an effect on the world in Elm. But other than that, being both from the ML family, it was very easy to port the Elm code, and I literally did the porting. I just copy-pasted and then modified until it compiled.
So most of your work in Elmish was basically copy and pasting? Sorry, just kidding.
Most of my work was keeping up with Fable. Copy pasting was done once.
That was also hard. I acknowledge that completely.
Yep.
Question. Many backend developers, they start looking at Elm because they can't JavaScript, and this is actually quite comfortable for them, because with Elm you can have complete app. You don't even need to to go that level. So how do you? Because as I understand it, you also came to Fable Elmish being backend developer. So what is your experience? How much did you have to be exposed to good knowledge of JavaScript when going from Elm to develop Elmish?
Yeah, good question. Obviously, Elm exists in its own ecosystem and it provides you with its own tooling, which I think is a great benefit to beginners, but it also has a downside. For example, they've had plans to provide their support for React Native, and they never did. So they can't run on native platform because they never integrated with the tools in the ecosystem. Fable asks you a lot more to begin with. There is quite a bit of ham to learn, but you don't really need to know JavaScript. So this management UI we originally wrote in Angular with TypeScript, and the conversion from one language to another was very painful. You had to learn tons of stuff, and the cryptic errors at runtime, something about the container not having something, were definitely productivity killers compared to just going with Fable. So we took the bite, we just rewrote our UI in Fable, and it was a pleasure. There's obviously a hump in terms of tooling, setting tooling up and getting up to speed. But once you're past that, it's a smooth sailing. You don't really need to know JavaScript at all.
Thank you.
Yep.
So Elm integrates their model with their implementation of this virtual DOM and so, and they claim to be extremely performant.
Yep.
Now in Elmish, Elmish doesn't exactly provide sort of it's more composable. How does this affect performance? Does that mean that, like, writing views and so on, you need to be aware of like which part of the tree you're or what you're updating and things like this?
Thank you. Excellent question. Yes, Elmish does not really own a specific renderer. We have bindings for render, but because we're following the same principles in terms of immutability, we can carry out exactly the same optimizations that Elm does. So we're still slower than Elm, given the React renderer, but not in the way that you would notice. The tests that there's a test bed in Elm where they run through to-do sample, adding lots of to-dos and completing some of them, and just rendering how and measuring how fast that happens. So I extended that and I used that as a test bed, and performance is not bad. It's slower, definitely slower than Elm, but it's not bad.
So is it hard was it hard to get to performance, or is it sort of also something that it's probably not the part that you just copy pasted, or?
No, there was no copy paste in the render. No, but two things. The optimizations brought us close to. So we started without any optimizations, and I think it was about third slower than Elm. With optimizations, it's maybe 20, maybe 15% slower than Elm. But the critical parts, and I think that's important. The critical parts you can optimize yourself. We give you the functions that produce lazy views, and for some libraries like D3, for example, it's essential. But we give you the tool to give you just smooth rendering, and that seems to be enough.